Hi everyone, today our chapter will be on chapter 9 which indicates the force and motion. Now let's check what is force and motion all about. Before we check out on the chapter, we need to know what are the learning objectives all about. Now in this chapter, the learner will use the equipment to measure time and distance so that the motion of the object can be determined. The learner will also use the data collected to calculate the speed of an object, and finally the learner will explain the results of applying a force to an object. What are the misconceptions that we can predict from this chapter? The first statement is that a force is necessary to keep the object moving. Is it true or false? The answer is false. According to Newton's first law of motion states that the object in motion stay in motion in a straight line unless it's acted upon an outside force. Now what are these outside forces called? They are known as friction, gravity, magnetic force, electrical force, air resistance, which literally slows or stops the objects. Let's check another statement. If an object is at rest, no forces are acting upon it. Is it true or false? The answer is false again. Why? That's because there are many forces acting on it, such as gravity, friction, air pressure, and etc. But they are literally all balanced. Let's move on to the next slide. Now, there are certain vocabularies in this chapter. For example, motion. Motion means the changes in position, direction of motion where an object is going. We have to draw a straight line which literally represents the object in the past and in the present. What is force? Force is a push or pull of an object, and friction is when two surfaces touch. It's always in the opposite direction of the motion. A force is literally a push or a pull. For example, when you push open a door or you have to pull open a drawer, you need a force. You cannot see a force, but you can literally see what it does. When the force is exerted on an object, it can change the object's speed, direction of the movement, and the shape. For example, an elastic band gets longer if you pull it. Basically, objects just keep on doing whatever they are doing unless they are acted upon an unbalanced force. These are the common examples. For example, the headrest in a car prevents a whiplash injuries during a rear-end collision. Your head goes forward and then jerks backward. According to the physics, the forces on the book are balanced up. This is because the table pushes upward on the book, whereas the gravity pulls downward on the book. The same application when a person stands. The floor pushes upward on the person, whereby the gravity pulls downward on the person, which literally makes the person to be at the equilibrium state. Let's say you give a book on a table a push. The book goes temporarily in motion, but friction from the table and gravity doesn't allow it to go further. Forces can be divided into contact force, where the objects must touch each other to exert a force, or a non-contact force, where the objects do not have to touch each other. For example, gravity, magnetism, forces due to static electricity. Forces can be measured using force meter, and the unit of force is also known as Newton and the symbol of capital N. This is the upthrust of the water, whereby the boat is balanced up and they are also in equilibrium state. Frictional force is when an object moves against another object and they feel the frictional forces, and it acts in opposite direction, whereby it makes the things or objects difficult to move. Friction can be useful. For example, friction between our shoes and also the floor. Friction between tires on the road and friction between the brakes and wheel helps the bikes and cars to slow down. Friction can be unhelpful as well. For example, if you do not put lubricant the bike regularly with the oil, the friction in the chain and axles increases. This makes your bike to be very noisy and difficult to pedal. Bikes, cars, and other moving objects experience air resistance as well as they move. And streamlining reduces air resistance. For example, racing cyclists, they crush down low on their bikes to reduce the air resistance. That's all for now. Thank you.